So last week we spent a lot of time distributing. I mean, that's all we did. Multiplying meant to just distribute. Well, this week we're going to undistribute. So it's kind of a little game of what would have been the multiplication problem that gives me 4x squared plus 6x. So the first step is to factor out the GCF. GCF, greatest common factor. It's the biggest thing that can be divided out of each term. So let's think about what 4x squared and 6x have in common. Well, both of them have an x, and both of them are divisible by 2, right? So I could undistribute 2x. So my greatest common factor is 2x. So I'm going to undistribute that. In other words, I'm going to make up the problem that would give me this as an answer. So what would I need here so that if I multiply by 2x, I get 4x squared? Well, that would be 2x. What would I need to get 6x back? I would need a 3. So I basically divided each of these terms by 2x. And the beauty about factoring is I can always double check. To check, just distribute. 2x times 2x is 4x squared, and 2x times 3 is 6x. It worked. What about 36y minus 24? What do they have in common? Well, 36 is 3 times 12, and this is 2 times 12. So these just have a 12 in common. So I'm going to put the 12 on the outside of the parentheses, and I'm going to undistribute it. So 12 times what is 36y? I need a 3 and another y. Minus 2. Double check. 12 times 3y is 36y. 12 times negative 2 is negative 24. Check. So both of these check out. Ooh. Gosh, 3x to the 5th minus 6x cubed. Well, I know 6 is really 2 times 3, so I know I've got a 3. But what else do they have in common? Well, they've got some x's in common, right? They've got 3 x's in common. Because remember, this is really x times x times x times x times x. And this one's really, well, let's write it as 2 times 3 times x times x times x. Now, I don't normally do this every time, but we're just going to do it to prove that 3x cubed is the greatest common factor. So this one has 3 and 3 x's, and this one has 3 and 3 x's. So I'm factoring out 3x cubed. So 3x cubed times what gives me 3x to the 5th? Well, really, it's going to be that x squared. Because remember, when you're multiplying, you add your exponents. So 3x cubed times x squared would be 3x to the 5th. And this would have to be a 2. Double check by distributing. 3x cubed times x squared is 3x to the 5th. 3x cubed times negative 2 is negative 6x cubed. So on the rest of this page, all you're doing is seeing what they have in common. And factoring it out. So let's press pause and you try these, and when everybody's ready, you can press play. So here are the first 6 of the try these. Hopefully you got them right. Now the other 4 I'm not showing because I want to see if you did them right, and I'm going to have you turn those in. Now the second way we can factor, because it wasn't always just distributing one thing, sometimes we were distributing twice. So if we turn it over, let's review multiplying binomials. So I'm going to use that box method because I like it. X plus 3, x minus 5. When I multiply x times x, it always gives me x squared. And then this was a negative 5x. And this is a positive 3x. And then 3 times negative 5 is negative 15. So when we add our like terms, we've got 3x and negative 5x. So they add to be negative 2x. And then this was a negative 15. So 3 plus negative 5 is negative 2. And 3 times negative 5 is negative 15. So those numbers in the parentheses always add to be this and multiply to be the last term. And there's not really any guesswork on anything. These are always going to be, if this is x squared, these are always going to be an x and an x. I just have to figure out what the numbers are. Now these two numbers multiply to be 15 and add to be 8. So let's think about some things that multiply to be 15. Well, I could have 1 times 15 or 3 times 5. Oh, 3 times 5. And both of them are positive. That works. Now you could double check by making your box and multiplying them back together. So I'm even going to show checking your work. X plus 3, x plus 5, x squared, 5x. So it'd be 3x and 15. My like terms do add to be 8x, and I do have 15 as the constant. X times x is the only way to get x squared. Now this one's kind of interesting. Negative 2. It's a negative number. Okay, so to multiply to be a negative 2, I could either have negative 1 times 2 or negative 2 times 1. That's the only way to get a negative answer. So now I need to see what these things add to be. So if I add them, negative 1 plus 2, that would give me a 1. If I add these, that gives me a negative 1. And this is really a negative 1 in the middle. So these are my two numbers, negative 2 and a positive 1. Ooh, negative 54. Well, that's going to take me a little while, huh? All right. Parentheses, x and x. Now we need to think about what multiplies to be negative 54. Well, I know 1 and 54 are an option, but I don't see any way that's going to add to be a 3. let's see, 54 is also 2 and 27. Now, I know one's going to be negative and one's going to be positive, but I don't think that's going to work either. I'll list it out, though. 2 and 27, or, whoops, that would be negative 2 and 27, or negative 27 and 2. Let's see. 54 is also 3 and 18. That's not working. What else multiplies to be 54? Well, 54 is also 6 and 9. So negative 6 times 9, or negative 9 times 6. These are all my options. Really, I mean, I could have, well, I'll go ahead and list them. I could have done the negative 1 and 54, or negative 54 and 1. If you list out all your options and then you add them together, what should they equal when you add them? Well, they should equal a positive 3. So that's 25, negative 25, 15, negative 15. Oh, 9 and negative 6 add to be a positive 3. Now, some of you may not need to draw out this chart if you know your multiplication really well, and you can kind of play the game in your head. What multiplies to be 18 but adds to be 11? So this one's positive, so I don't have to worry about those negative nasty things, huh? So 1 and 18, 2 and 9, 3 and 6. Do any of those add to be 11? Those do, and they're both positive. Now the next two examples have something interesting. This is a positive number at the end, but a negative that we're adding to be. So how would that happen if I have two numbers that add to be a negative but multiply to be a positive? Well, they both have to be negative. So my options are, I could have a negative 1 times negative 10, or a negative 2 times a negative 5. Now this one, if I add them together, I get a negative 11. But these, that's a negative 7. So x minus 2 times x minus 5. Go ahead and pause it and try the next 3. And then press play when you're ready to see the answers. How did you do? Hopefully pretty good. So I want to do one last example. Ooh. Gosh, maybe 2 examples, because what do we do if there's only 2 terms? Oh, well, that's like having x squared plus no x's minus 36. 2 numbers that multiply to be negative 36, but when I add them, they disappear? That's that special pattern. What about 17? There's a hint to the side. Look for a greatest common factor first. Okay, so That's going back to that first page. Do we have anything in common that I could divide out of each of those terms? Well, they all are multiples of 2. So this would have to be an x squared. That would have to be a negative 5. 2 times negative 5 is negative 10. And this would have to be a 6. Now I can factor what's in the parentheses. I know this has to be x and x. Ooh, multiplies to be a positive 6, but adds to be a negative 5. So they both have to be negative. Negative 3 and negative 2. Finish the rest of these to turn in.